Hi, and welcome to episode 8 of Every Semicolon. I was going to run through some of the old videos. It's been about a month since I've done one of these, I think. At least according to the YouTube video, it says about a month ago it was uploaded, so I believe it. Yeah, I was going to have a look at the old ones and see sort of what I was doing, where I was up to. I had a quick look at episode 7. I was doing those editor window or shortcuts and that sort of thing. It's quite a boring video, so this time I'm going to do something a little bit different. I want to get going on ballista mechanics. I haven't really decided. I was having a look at Angry Birds Space, and it shows the trajectory of the birds, and yeah, that's obvious why they're doing it, I guess, because it's got much more manipulative mechanics in the gravity of planets and things like that. So seeing the trajectory is important because, unlike the first one where it was about, you had to. The point was basically you are sort of figuring out the mechanics of the slingshot and shooting it based on what you think the trajectory is going to be, trying to hit the thing you want to hit. Whereas in this one, you can just hit whatever you want to hit because it gives you the actual trajectory. And I'm not sure what I want to do in this game yet, so I was thinking I'd put in a trajectory indication, and then I can take it out later if I want. But it just seemed like something fun to do. So it's, I guess, the sort of thing you'd see in like a modern shooter game, or Gears of War or something like that, where you're going to throw a grenade and it will show you sort of an indication of where the grenade's going to go. I'm not going to bother with showing subsequent bounces and things like that, because that's not really necessary for this game. All I want to do is show the initial, this is where you're shooting at, sort of thing, and then we'll see how that feels. I'll probably leave it in for a while and make a decision based on how, I guess, the difficulty and where I want the difficulty of the game to be. Is it in trying to aim your shots based on not trial and error, but learning the mechanics and of each weapon, or is it more to do with hitting things in a certain way, picking the blocks to hit, right? And then obviously if it's more about picking the blocks to hit and destroying things in a certain order, which is quite possibly what the game's going to be about, considering you can choose which direction to fire from, and that sort of thing. You don't really want to have to worry then about hitting the right thing. You've figured it out, like, okay, I've had a look at the situation, I want to take out this block, and then this bit's going to crumble, then I can attack that bit there, and then I can then come from this angle over here and hit that, and so forth. If you then have to deal with, well, I've planned it all out and now I've messed it up because I picked the wrong angle, that's not very fun. So I'm probably going to leave the trajectory thing in based on how I think this game's going to work, but it is sort of a very fluid design process at the moment. I don't really have a huge, I'm not really that focused on the fine minutiae of the game yet. Even, I guess, I do sort of macro design in terms of just the mechanics and the what we're trying to do here. So alright, ballista. Okay. So at the moment we've got this thing here, which is basically, it gives you the trajectory on sort of one axis. So as you turn left and right, this thing will turn left and right with you. So we fire it up. We can do that, and you can see which way it's going to shoot on that sort of XZ plane there, and that's pretty helpful. But as soon as you get down to this angle, you have no indication of your trajectory on the sort of Y axis displacement of the bullet. So that's what I want to do today. I'll focus less on, I don't know if I'll actually get into the ballista stuff, because the ballista still doesn't have its moving components and that sort of thing, so won't worry too much about getting all that happening. I think Shane's done some block artwork as well. I think I'll leave that for the next video before I get into some of that. And I might have a quick look at it before I do the video, just for the sake of I don't really want to waste time going into a video thinking we can do some art stuff and then finding that the art needs tweaking and that sort of thing. So that's really the only part of this video series where I guess I won't be doing everything on film. I'm not going to won't do any work. I'll just check the art out and then let Shane know if any changes need to happen, and then from there I can I guess make that happen and prepare the art for implementation and what we'll see in the videos. Okay, so we'll stick with this guy, the catapult. Catapult trajectory, probably not going to be a thing. The ballista, obviously we can tilt it. Catapult, I'm not really sure if you'll be able to change sort of the angle of it, but definitely changing the power will change the trajectory. So okay, let's introduce a few things here. What actually happens? I change the angle in this way, which is just turning the thing, and then I change the force. I want to introduce an angle, I guess, a variable to the weapon. So let's see what I've got here. Do I have? Yeah, I've just got one weapon script. Let's introduce the angle now. Starting Y angle, aiming top Y angle. Those are, I believe, for on the Y axis. Okay. Shoot direction, and that must be an angle there, I believe. There's the problem with having a little bit of a break between videos. I don't actually want to. I'm going to try very hard to not have a 1 month break between videos again. I've had some people go, asking if I'm going to continue this video series and what's going on, and yeah, I mean, absolutely, I'll continue this all the way to the end, even if it takes 10 years. I'm not going to work on this game without doing these videos, and I'm not going to not finish this game, essentially. But I'll try to do it in a reasonable amount of time. I have obviously work, and I'm also working on some other projects in the meantime, and I've also got the art to wait for. So until we get to a point where the art's coming through quickly, and I sort of have the time to do at least a few of these every weekend, maybe, or throughout the week. It might be a little bit slow going, but I think so far so good. Pretty good progress in the first couple of weeks, and now I'd like to get back into it and do another batch of videos, and hopefully just keep rolling until the end. So rigid body was adding relative force, shoot direction, and some sort of power amount, have range here, and then the shot force, which I guess was that slider, the up-down slider. Force mode impulse. So that's okay. This is well, what am I do? I mean, that's fine. Just to make it a little bit more obvious to myself what's going on, even though it's exactly the same. I'm just going to set the velocity of the projectile. Okay, so that's going to be the exact same as it was before, I believe. Famous last words. Holy shit. Okay. What I want to do is I actually do want to set the velocity of it explicitly, I think, for my trajectory calculation, because otherwise, I'm going to be basing on just fairly standard projectile motion methods. So the initial velocity for the projectile, I'm going to actually want that to be explicitly set. So force mode impulse, so it's not. I think there's force mode velocity change, which would work. Would be the same as setting the velocity. Okay, so what have we got? Catapult. Shoot power range. See, that's very, very large, considering the. I guess the mass might come into play in this relative adding force to a thing. and I could take that into account in my calculations, but I think for as far as I know, every weapon's going to fire the same sort of. Yeah, I don't really want the mass of the projectile even to come into play in the gameplay mechanics of it. So what I'll do is jump out into the catapult prefab and let's drop this down to. Let's have a look at 40 and 80. Start to get an idea of what we're dealing with. Okay. Right, so at the lowest, 40. That's center. Alright, so let's drop it down to 10 and 60, let's say. 10 will just be a little drop. Okay, probably too small. 20. 60. Pretty big. Hitting our own dude, sort of big. Alright, 20 and 50. I'll just say that's spot on. No need to test any further, we can tweak it later. So 20 and 50. Alright. So we're explicitly setting the velocity of our bullet, which is cool. Now, what I want to do is create maybe another game object inside the weapon to draw this this trajectory path. So for now, I'll just get the code working. Gameplay, weapon. We'll put it in weapon. Yeah. So we'll call it projectile trajectory. You'll see here I've changed my. Still this. I need to. Maybe if I just try. And do is just delete all of that. And resync my project. Open it up. No, just doesn't like it. How do I? This is going to be probably a common theme continuing for the rest of the project rather than me just. I don't want to spend a lot of time figuring out what the hell's going on with this thing. It's a C# project, right? Is it? But it seems like maybe the shortcuts aren't C# shortcuts. Edit. See, all those are fine. Tools. Options. Maybe it's a. Yeah, I really should just figure that out. Maybe outside the video at some point, rather than fumbling around for a few moments every video trying to figure out why the shortcuts aren't working properly. Okay, projectile trajectory. So most of my variables are stored in weapon. Yeah, so as I was trying to say, I've changed my template to this for another project. It's sort of currently where I'm sitting on preference, minimizing the amount of regions. Sometimes I want to put properties and private and public variables together, base them, combine them in a group based on purpose rather than whether they're public and private. Okay, so we've got shoot direction, which we're going to change to angle. So what we'll do is we'll keep a reference to weapon, and we'll have some methods here for getting values. Say get position, we'll call it get displacement at, well, we've taken the weapon, we can get the transform from the weapon, we can't just get the position. Well, what do you get displacement at time? And does it need to be vector 3s? Get position at time. Okay, so we're going to change shoot direction to be an angle. The x-axis angle. Let's default it to 25 degrees, perfect. Alright, so when we shoot, okay, this can be, we want the shoot direction to relative force. Okay, so we want our transform, which this transform dot forward, quaternion dot Euler. Okay, so we'll make a quaternion rotated the angle around the x-axis. Might have to be negative. I guess we'll find out, but I'll put it as negative for now. We'll see if that works. We'll multiply that, so basically rotating the forward of our transform, our weapon, around that by that amount. And then we're going to shoot in that. That's going to be our shoot direction. Previously that is now created via this. Yeah, that should be. Find out. I think that's right. Okay. So, alright. And also, I'll check in. So, what we're going to do is we're going to draw this stuff on draw gizmos selected. Right. So, to get these sort of calculations to do this trajectory stuff, it's fairly common physics stuff. What you want to search for is trajectory or projectile motion. Yep. Okay, so here is a Wikipedia page, projectile motion, and basically, as you can see here, we can get the horizontal, vertical components of the projectile motion with these formulas, and here's some stuff we'll probably use as well for. You can get the time to reach the maximum height, so the time to reach this highest Y position, time to reach the ground, which is time to reach, I guess, the same vertical displacement or position as the start. Get the displacement in the x direction, which is sort of the at that point, I guess, how far it's travelled. Oh no, well, it's got a t here, so displacement in x direction is this again. Displacement in y direction is this again. The range of the projectile, maximum height. Okay, so what we're not going to use a lot of this. We'll use these two, I think, because we will want to. I just want to draw it to the point where it reaches the ground a little bit further. So I might go time to reach the ground, and then another couple of seconds worth of tail onto that. Time to reach maximum height. Nah, probably don't need that. Displacement in y direction. So these are the ones pretty much we'll be using. Okay, so let's have a look. Okay, so I'll bring up this on the other page, and I'll just sort of talk through it as I write it. I have done this before in another project, so hoping it'll go well. Yeah, it's fairly straightforward, but these sort of things can be a pain in the ass sometimes, so I'll just copy these in for a moment. Nope. Alright, so basically the horizontal component is so they've got x equals v0 times cos angle times t, and the y, they have v0 sine angle times t, and then minus 0.5 times g, just gravity, times t to the power of 2. Okay. So those are basically, that's it. Those are the two methods we need. So what I'm going to do is start writing it. So from the weapon we can get the force, shot force in the angle. We want the angle in radians, so what we're going to do is go rad angle. Wow. I'm using a different keyboard actually today, because my shift key on the other keyboard is starting to play up. Left shift, unfortunately. So I'm thinking about buying a mechanical keyboard, so that probably means in future videos there'll be even a louder clicking of the keys. So get ready to enjoy that action. Right, so rad angle equals weapon dot angle times mathf dot degrees to radians. This is a unity const here. It's basically you multiply by this number to convert from degrees to radians, and here's radians to degrees. So that's handy. Okay, so float x displacement equals, so a weapon dot shot force, and shot force is, okay, so we're going to need to do the let's get the shot force equals just do yeah, hold on, I'll do that in a sec. Weapon dot shot force times f dot lerp between weapon shoot power range dot x y. So this is finding what our shot force is based on this 0 to 1 variable here. So basically a percentage, a range, a distance between these two variables here. So we're going to interpolate from one to the other, and what I can do now is get the x velocity. This is the initial velocity in the x-axis, and as you saw before, what they're doing here is that's actually getting the initial velocity in the x-axis by multiplying it by cos right angle. And same again for the y, except with sine. So then x displacement is basically, because there's no in the horizontal axis, there's actually no forces working against it, essentially. Time. Okay. So the y displacement, you see here, it's exactly the same, except then they introduce, they subtract gravity's influence at that point in time. So 0.5 times. This is actually this is the thing that messed me up. One of the things that messed me up a bit when I was doing this stuff the first time on an older project. I was using these calculations, and it all seemed like I was doing it fine. Except all these calculations aren't using a negative gravity axis, which this is going to be negative. By the default, 9.81. So I actually want to use mathf absolute to get that as a positive number. Okay, so time times time is a simple way of just squaring it. So it's y velocity times time minus 0.5 times blah blah blah. Okay. And what we have there is displacement at time. So I guess I'll return this as a vector 3. Well, how do I want to do this? Maybe I should do this as a vector 2. Let's do that. The x and y, yeah, it's like it's a 2D sort of calculation. And my position at time, I want to use the, I might get the weapon transform. Okay. Now, this is an example of where I'd like to group fields and properties together. So, yeah, I think I just prefer this sort of region style, actually. And I've just done this. I've probably mentioned this many times before. This is a way of and I can. It's a way of caching a variable, so I don't have to grab it each time. It's a bit faster. And the reason I'd normally just prefer to just grab this variable directly and not have a property here, because the property then has to do an if statement, which is obviously slower than nothing, which would be just if what I was doing if I was grabbing that. But I'm going to be running this in the editor on draw gizmo selected. So in the editor, this private variable won't be set yet. What I can do though is do conditional compiles. I might do that in a sec. Okay, so get position at time. We're going to get displacement at time. And then we're going to get the weapon transform. Yeah, I'll just do it like this. So return weapon transform. Okay, so this is an example here, I guess, where, in fact, what I might. It's interesting. How do I want to do this? I might just do something weird. I don't really generally do this sort of thing. No. Yeah, no. Alright, we're not going to do it. We'll do it like this instead. If Unity editor else, and if some people might consider this to be a bit over the top. No, I sort of was thinking about what I was thinking about doing basically was going, defining a variable if it was the Unity editor, or defining a property and basically going this else and going. I would have to do it around that as well, but basically just making doing this sort of thing, and then always using this name, which in the editor would be a property, and in the built application would be a variable or a field, which I'm not going to go to that extreme. It's a bit over the top. Alright, so weapon transform dot position plus weapon transform dot forward times displacement dot x plus weapon transform dot this probably world space up with what we want times displacement dot y. Okay. So now what we're going to do is for loop. We'll just do for now. We'll do like 100. So what I'm going to draw 100 lines basically. 100 lines. Get position at time. Okay, I'm going to do. Yeah, I can't help myself sometimes in optimization. Yeah, let's do it. Previous pause. Next pause. I plus 1 times we need an increment variable. Okay, so in this case I'm just going to make each one. Yeah, so I could say I want to do it over 10 seconds. Yeah, okay, I'll do that too. Show time 10 seconds. In num segments equals 100. I got insert here. Okay. So basically, if I want to do over 10 seconds with 100 segments, that means 0.1 each time, which is show time divided by number of segments. Yep, okay, so let me tell you what I'm doing here. Alright, so that. Yep. So I'm going to say, I want to draw this for, well, I'll do it. soon I will stop. And might just cap this out. Just to prevent it from me dragging it to an extreme and it dying. Okay, so maybe it still could die based on, anyway. No, not really. So what I'm doing here is I want to draw, well, maybe we'll show it and we'll see if it looks right, and I guess that'll be a way of talk it through that way instead. Just delete that. Okay, so catapult. We're going to give it the projectile. And apply that. Delete. Cool. Alright. Obviously it's not starting from the right position currently. Let's also change the colour so we can actually see what we're doing. Red seems like a great idea. And might as well do this over here. It's going to be plus weapon dot something offset. Nope. Bullet instantiation point. Okay, cool. Alright, so there's 100 individual lines in here, and if I go to this one, get out to 10. No, that's not working. Let's have a look. Increment, show lines for seconds, blah. Okay. So my increment, in this case, what have I made it? 10 and 10. And 10 divided by 10 is 1. So theoretically, it should be going 0. And then 1 times 1 is 1. Previous point is next pause. Previous pause equals next pause. It comes in here again. Next pause is 2 times 1 is 2. So if you go from 1 to 2. And it should do that for 10 times. So my theory was changing this would make no difference. Because at If I went, yeah, in this case it's 100 line segments. 10 divided by 100 is 0.1. So each time it increments by 0.1. 0.1 100 times. And being 10 still, same as 10 times 1. Okay. Apparently not, though. Sure everything's all on the up and up. Ah, max. Whoops. Okay. There we go. Right on. So if I then change this to 10, it's exactly the same, but there's less segments. Basically, just reducing the quality of the line. So now there's 1, 2, 3, 4, 5 segments in my line. So 100 segments is a nice smooth line, you know, depending on the range. Okay. Let's have a look and see if that's right. That's the first fun part. I'll jump in here and change shot force. Okay, so we've got quite a limp one here. Let's just go, I want to hit right there. Let's see what happens. I think my shot force, I think it was the wrong catapult. What catapult is this? 4. And we've selected something else. Alright, so let's select whatever one that is. Okay, here it is. Catapult 1, of course. Right, so you get a game. Turn gizmos on in the game for now. Right, so that's meant to hit right there in that wall. As you can see, our projectile follows the path perfectly. So that's cool. I mean, that's what's happening there is the physics system, of course, is just using standard, you know, Newtonian style physics, and that's the same sort of calculation we're using here. Things come into play like drag. I'm not really sure how to modify the calculation based on drag. It might just be something like 1 over drag multiplied by that or something. Irrelevant, because at the moment, and probably forever, and you know, if it changes, I can adjust it accordingly. But you know, you see no drag. Mass doesn't come into play in this calculation, so that's cool. If I wanted to do something like I was doing before, where I apply a force to it and the mass maybe impacts its velocity based on that force applied, then I could probably, you know, calculate what the velocity is based on the mass and the force, and change it accordingly. But I kind of just like setting the velocity directly. I think that's probably better for what I want to do. So that's pretty cool. But obviously drawing a line like that in the game isn't really going to be ideal. What I'll ultimately do is get a some art made up to follow, to, you know, do a cool something based on that. I'm thinking more like a series of, you know, little block pieces going along the line. Otherwise, I could do something like grab this and with more segments, displace vertices, and do sort of a dynamic mesh following the line. That would be quite simple too. But I kind of like the idea of having a moving line, if you know what I mean, like shows also the trajectory, but also the direction, not velocity necessarily. Possibly velocity. I mean, so what I'm thinking there is like Yeah, velocity's pretty quick. Where's our gizmos at? Ah, it's not selected. Select all these. Cool. Yeah, just having maybe little segments, little blocks moving along the line, sort of a segmented line, if you will. So I could do something like that now. Basically grabbing a cube, perhaps squashing it down a bit, and just having this series of these maybe follow along the line. And then you have to orientate them by looking at the point ahead and looking in that direction. So if I was to do that, okay, let's have a quick look at this. So projectile, well, let's call it trajectory indicator. Sure. Okay. I mean, our prefabs. We'll put it under effects for the moment. Okay, let's just do it as part of this, and we'll say trajectory indicator graphics. Punlick. Typing is not up to scratch today. Okay, so that's our trajectory indicator graphics, and we want to give it a speed. Indicator speed. Sure. 5 meters a second. And cool. And I'll just have a make it a list. Or better yet, maybe a queue of objects. Right. Float. Okay. So what we're going to do is every well, in this case, every 5 seconds we want to instantiate one of these indicator graphics. I'm wanting to put a component on it to follow the line. Maybe even to destroy itself. Maybe I don't want a queue after all. Maybe I don't need any of that. Yeah, let's take that out for the moment. instantiates indicator at the weapon dot for instantiation points. Let's give it identity for now. I'm going to have a trajectory indicator component. And our trajectory indicator component, it's going to have a method called set trajectory this, give it an initial position, and speed. They're separate. Set speed equal to speed, and okay, cool. Right, let's jump back out. We have a script called, maybe I should put these into here, and trajectory indicator. Okay, so it's going to have a speed, it's going to have a T position, and in its update get the transform. It's going to have a projectile trajectory, these public methods, now set trajectory and set speed. And T position equals T pos. Public void set speed, okay. Now its position, what I'm going to do is actually first increment its T position. And we're going to set its actual position to projectile get position at time T position. First we're going to go if T position is greater than projectile trajectory dot time seconds, show line for seconds. we're going to destroy game object. And we'll just return. Alright, so what that means is it's going to just keep moving along the trajectory line until it goes past the trajectory line, how far it's drawing in seconds, and then it will destroy itself. We also need to set, so I'm just going to pick an arbitrary distance here. Look ahead. Time. .5. Look at. Okay. So back to here. It's like that. Errors. What's up? Object 33. Yep. New transforms of displays never used. Cool. No warnings, no errors. Fantastic. So we want to go to our new trajectory indicator and add on this component. That's all good. We want to go to our catapult. Select that. Drag it in. I can also just do it directly in here. Assign that there. Alright. Wow. That was cool. Try that again. What are we doing? So it's less than 0, new indicator. Oh, speed. Indicator speed is not. That's in meters per second. I'm adding it to the time. Okay. It's a bit trickier handling that. Let's just do it based on time. Yeah, let's add a second to it each time. A second per second, 5 seconds per second. Even 5 seconds per second shouldn't be too bad. I'll also go back to this and change that. Alright, so what's it doing? Okay. So now that's not based on meters per second, which is fine. I need to now indicator spacing. Okay. Well, let's use Unity for what it's good at and start tweaking these as we go. 0.1, 0.01. How about that? Yeah. Nice. Okay, that's not too bad. So what was that? That was 0.1 and 0.4. And this dude I think needs to look ahead by less. I probably do want to maintain a list of the list or something. No, I guess it doesn't have to be a list. I just want to show these when the thing is selected, and I want to sort of pre-bake or pre-simulate, basically just pre-fill out this thing, which is easy enough because I just need to loop through by this amount over sort of this amount, and instantiate one of these at all those points in time. But I think that's starting to work out, and I do sort of need to stop this video now, get something to eat before I die. So as you can see, they're ending. Are they ending? That's just the thing that's happening. Okay, yep, here we go. Once they reach this point down here, they should stop. Okay, here's an example. Oh, that's the start. Of course. Alright, getting there. Come on. They should destroy themselves. Pop, 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 pop. Excellent. Alright, that's cool. Yeah, that's probably the effect I'm after, actually. Maybe little arrows or something. Nah, arrows look weird. This shows the direction based on their movement. So if you can imagine, oh, I don't know if it linked up to anything, but I think that's quite handy. Yeah, I think that's pretty cool. Probably need to tweak the spacing, and maybe we'll have some graphics in there instead of just use stretched cubes at some point, but they do the job. And having this kind of cool lattice work of trajectories is pretty sweet too. Alright, that's going to do it. Pretty quick one, it's an hour. I think I might do some more maybe today or in the coming days. Taking this to the next logical step, and then maybe getting the ballista in, and also have a look at those blocks and start getting some blocks in. It's good to see sort of things coming together. I think this is probably pretty helpful to people too. It'd be good if people, I've seen people ask for this sort of stuff before on the Unity forums and that sort of stuff, and it's really easy. So it's I think sometimes this stuff can be a good learning resource, and I'd like to do some short videos like this where I calculate projectile motion paths. That's a good little resource to have. Obviously it could be done a lot quicker, but I have to do it as part of this whole developing a game thing, so that's cool. I'm happy with that. Yep, okay, so next video, blocks, more trajectory stuff, ballista stuff, it's all going to start happening. Getting there pretty quickly now. I think it's all going to start coming together. So thanks for watching, and please give me questions, leave comments, feedback in the comments on YouTube, or I post this on the Unity forums, on my developer blog, and on southeastgames.com. And I'm actually working on a couple of other projects, so I'm going to be doing there's something I'm releasing on the asset store quite soon. I've had it ready to go for quite a while, and I'm just sort of got to get it just polished up and put it out there. So I'll talk about that whenever I do that, and a couple of other exciting projects I'm working on, which I hope to be able to start showing some demos of soon. So thanks for watching, and yeah, please feedback's great.